CVPR 2025 wrapped up in Nashville this June, delivering another impressive showcase of computer vision research. This year brought together 9,375 attendees from 75 countries, all buzzing around 2,878 accepted papers. That's only 22.1% of the massive 13,008 submissions, so you know the ones that made it are something special. And in this video, I'll walk you through the papers and models which are conference's top award winners. Models like VGGT, which rethinks real-world 3D scene understanding. If you care about 3D annotation, video understanding, or foundation models, this video is for you. See it till end. We start by mentioning the best paper honorable mentions by CVPR. In that category, first one is MegaSAM. Accurate, fast and robust structure and motion from casual dynamic videos is chosen by CVPR. Most 3D mapping methods, like SLAM, work great in perfect conditions, lots of camera movement, still scenes, and controlled capture. But that's not how most of our videos look. Casual videos often have little camera motion, moving people, cars, and unpredictable views, and traditional methods fail here. MegaSAM changes that. It's built for dynamic, everyday videos. It uses depth clues from single frames in a motion probability map to spot what's moving. Then, it combines all that in an uncertainty-aware adjustment step, figuring out the best camera path and scene layout even with shaky footage and moving objects. The result is a more accurate, faster 3D maps from regular videos, perfect for AR, VR, robotics, and autonomous systems. With MegaSAM, any video can become a reliable 3D scene. Next, an honorable mention is navigation world models. Most robots today navigate with fixed behaviors. They follow exactly what they were trained for. If you teach one to move through hallways, it won't adapt when you suddenly want it to avoid a construction zone or follow new rules. Navigation world models changes that. Instead of reacting step by step, it predicts what the robot would see as it moves, like imagining the future. Using a powerful conditional diffusion transformer trained on massive amounts of first-person video, it can mentally explore different routes, check if they meet new constraints, and pick the best one. This means it works in familiar spaces and can even plan in completely new places from just a single photo. It's a leap toward navigation that's flexible, predictive, and truly adaptable. Next, in Best Student Paper honorable mentions chosen by CVPR. Generative Multimodal Pre-training with Discrete Diffusion Timestep Tokens was selected in as Best Student Paper. Vision language models have a tricky problem. For understanding tasks, they need to compress an image into abstract meaning, ignoring extra details. But for generating images, they must keep enough detail to recreate them in high quality. Most current models treat images as grids of patches, or spatial tokens, but this structure doesn't match how language models naturally process information. It's like giving them a language they can't speak fluently. This research paper fixes this with discrete diffusion timestep tokenization. Instead of spatial grids, it organizes tokens by how information disappears during image generation, creating a natural, layered hierarchy, like sentences in language. This makes it far easier for the model to understand and generate images at a high level and could shape the next generation of multimodal AI, balancing deep understanding with stunning image quality. Finally, Best Student Paper in CVPR 2025. Neural inverse rendering from propagating light is selected as Best Student Paper. Most lidar systems only use direct light, the beam that bounces off an object once and comes straight back. But in reality, light also bounces around multiple times, carrying hidden clues about the scene's materials, shapes, and layout. Traditionally, this indirect light is thrown away as noise. This new research changes that with a time-resolved radiance cache. Think of it as a smart memory that records how light moves through a scene over time. First, it stores all that light transport data. Then, a neural network quickly searches it to reconstruct scenes more accurately, even in tricky lighting. It can separate direct and indirect light, relight scenes, or even create videos showing light movement from new angles. This could make autonomous vehicles and 3D scanning far better in complex conditions, blending physics and AI for next-level vision. Finally, the best paper of CVPR 2025. Visual Geometry Grounded Transformer is awarded the best paper in CVPR 2025. Visual Geometry Grounded Transformer takes a fresh approach. Instead of solving 3D geometry through slow optimization, it predicts it directly. Give it anywhere from 1 to hundreds of images, and it instantly outputs camera positions, depth maps, 3D points, and even motion paths. Its alternating attention layers let it zoom in on single frames for detail, then connect the dots across all images for global accuracy. And it predicts multiple 3D properties at once, boosting performance. It's over 40 times faster than some leading methods, while staying accurate. This makes real-time 3D mapping for AR, robots, and self-driving cars much more practical.